Okay, so with Sonnet 4.6 release, Anthropic also introduced a few very interesting and important developer tools that nobody's talking about. These are not only going to save you money, but they will also improve the performance of your agent. Now, in particular, I'm talking about programmatic tool calling. This feature has been available for a while. The idea is that instead of your agent trying to load everything into the context window, you can make specific calls to a specific tool just by writing code. And this way, you will not only save on the tokens that the agent is going to be using, but you're also improving on the accuracy of the calling. Now, Anthropic has been doing some really interesting engineering work, and they have been one of the companies that is actually openly discussing their innovations, which is really cool to see. Now, the question is why this works better than JSON structure that you provide to your agent for tool calling. Well, these agents or LLMs are specifically trained with code. They are not trained for tool calling, and writing code is pretty natural to them. Now, the question is why even pay attention to this? Well, I think Anthropic has a track record of when they release certain tools or technologies, the rest of the industry actually tends to adopt them. This happened with the introduction of MCPs or Model Context Protocol. Now, every company is building MCPs. We saw a very similar trend with agent skills. Pretty much every coding agent out there is introducing agent skills or supporting them now. The only other time that we have seen wide adoption of something coming out of a frontier lab was probably the chat completion API from OpenAI. Okay, so let's put things in the context. And why exactly do we need programmatic tool calling? So for that, we need to look at this context window problem that every agentic company is trying to solve. And this has been made worse with the introduction of protocols like MCP. Now, here's what usually happens. Let's say if you have an MCP connected, it's going to have different tools. All of those tool definitions are loaded into the context of your large language model. Now, during interaction with the user, it's going to make tool calls. The outputs of every tool call, and then subsequent tool calls are also put into the context window. You also have the system prompt plus user memory and the actual user messages and responses. And as a result, you can see that most of the context window is going to be polluted or used by unnecessary things that you should be able to avoid. Now, last year, we started seeing this concept of context engineering appearing everywhere. And the idea is that you want to provide just useful information in the context window and discard everything else. Now, in general, our tool calls play a very major role in this. Now, here's what usually happens. When the user query comes in, a coding agent like Cloud Code is going to make a tool call. The results are passed on to the context. That is going to make another tool call. And this process repeats. Every time you invoke a tool, the results are passed on to Cloud Code and put it in the context window. Now, the idea of programmatic tool calling is a little different. In this case, instead of directly calling the tool, Claude or your coding agent is going to write code to invoke certain tools in a sandbox environment. The coding agent can define the order of how those tools are going to be invoked in this sandbox environment. Now, in this case, we will provide the code written to the sandbox along with the actual input, and the only output is going to be the final summary or final answer. So anything that happens in between stays within the sandbox environment. And as a result, the coding agent is going to be only seeing the final results. Hence, you're going to be using a lot less tokens compared to if you are doing tool calling. Now, one thing is very important, that This is not just one company idea. Other companies have been exploring the same idea. Let me walk you through a timeline. Back in September 2025, Cloudflare actually published a report called Code Mode, the Better Way to Use MCP. And they also came up with this idea of programmatically invoking different tools rather than going the traditional tool calling within an MCP server. And they showed that you can save from 30% all the way up to 80% on tokens if you adopt this sandboxed approach. In November 2025, Anthropic published this article called Code Execution with MCP, Building More Efficient Agents. And they pretty much came to the exact same conclusions as Cloudflare. Then later in the month, Anthropic released the full advanced tool use. So this included tools like Tool Search Tool, which is another way of looking at or looking for specific tools within an MCP server, which saves you on tokens that are going to be used by the agent. And with that, they also had this concept of programmatic tool calling. Now, their results at that point showed about 37% token reduction and improved accuracy on several benchmarks. And just like anything released by Anthropic, the usage kind of exploded within the open source community. So you had implementation from Block's Goose agent, which added code mode MCP support. Then there were other GitHub repos that implemented the programmatic tool call. Now, a good example of this is Light LLM, which basically added native supports across different providers. And this brings us to today. So basically, move this from beta, so it's now fully supported. And they also added dynamic filtering for web search. We're going to look at that later in the video. But both of these concepts together can really save you not only on token cost, but also can improve the performance. Code execution has been part of Gemini offering since Gemini 2.0. And now even OpenAI GPT since 5.2 has added support for 20 plus different tools behind their API. Now, the key insight is that LLMs are trained on billions of lines of code, especially with coding agents. You can see that they can produce and understand code, but barely any synthetic JSON tool calling formats. So you want to do or let the agent do what they are good at, and that is writing code. Okay, so what exactly does this looks like in practice and what type of results you should expect? That's exactly what I want to talk about in the rest of the video. With Sonnet 4.6 release, Anthropic also introduced two different set of tools. One is web search, and the second is dynamic filtering capabilities. Both of these are powered by programmatic tool calling. These tools were previously available, but now Anthropic is introducing improved versions of these. And with this, they say Claude can now natively write and execute code during web searches to filter search results before they reach the context windows, improving the accuracy and token efficiency. So like maniacs, these models used to just dump everything into the context window whenever they used to do web search. So this will pollute the context window with irrelevant information. Now, they say that after doing the initial search, Claude writes code and execute code to do post-processing on the query results. And using the programmatic tool calling, by doing dynamic filtering, they are going to post-process the results and only put the relevant results in the context window. So this is a step that happens before injecting information into the context window. So they were specifically looking at two different benchmarks. One is browser comp and the other one is deep search QA. And they saw an average of 11% improvement, while average of 24% fewer input tokens. This is significant. This kind of improvements are usually expected if you have a major model version upgrade. The browser comp benchmark tests whether an agent can navigate many websites to find a specific piece of information that is deliberately hard to find. Now, with this new dynamic filtering, they saw that Sonnet went from 33% to 46%. We're talking about almost 13% improvement, whereas Opus went from 45% to 61%. And again, this is dramatic improvement on this one specific benchmark. But we do need to keep one thing in mind. This is not always going to result in reduction of token usage, and I'll explain why later. Now, this second benchmark, Deep Search QA, basically tests the capability of the model to find all the correct answers via web search. So a question has more than one correct answers and it's supposed to find those. Now in this case, again, we see an F1 score improvement from 52 to 59% for Sonnet 4.6, and Cloud Opus also saw almost 8% improvement. Now, here's the most important thing. They say token cost will vary depending on how much code the model needs to write to filter context. So this price weighted token decreased for Sonnet 4.6 on both the benchmarks, but increased for Opus 4.6. So that means Opus was writing a lot more code, although the number of tokens in the final output were reduced. But since Opus was writing a lot more code to filter those results, the weighted or the price weighted token actually increased for Opus. So this is important to keep in mind. You're not always going to see reduction in token price, but that is an expectation. Okay, so how exactly does this work? Well, if you're using the search API, you don't have to do anything whatsoever. You just provide or use the exact same search API with data fetching enabled, and Anthropic is now going to automatically use this capability to reduce the number of tokens that are going to be returned with only the most relevant information. Now, there are also a number of other tools that went out of beta and are now generally available. So one is code execution sandboxes. Memory is another one. Programmatic tool calling, then tool search and tool example are basically some cookbooks that Anthropic has provided. They also released detailed documentation on how to use this with some really quick examples. So for example, if we look at this in here, you will just provide a list of tools. The structure remains very similar to normal tool definition. You provide what the tool does along with the name, then the input schema, what are the required parameters, and what is going to be the output schema along with the definition of the tool. And then if Claude needs it, instead of doing function calling, it's going to just write code to execute this specific tool for you. Now, I suspect this is probably going to become a standard in the industry, just like MCP and agent skills. Now, do let me know if you have a specific use case for this and what are your thoughts. And also, if you are interested in more detailed tutorial on how to use this with other coding agents, let me know. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.